with David Higgins now. He's Senior Director and in the Field Technology Office at CyberArk, and he'll be talking about who really has access to your data, the critical role of identity security in the modern IT environment. David, thank you so much for joining us today, and the floor is yours.
Thank you very much. Brilliant. So thank you for the introduction. I'm just going to quickly start sharing my screen and then fire up some slides. So hopefully that's coming through. So yeah, brilliant. Thank you for the introduction. And exactly as you just mentioned, going to talk to you about a topic of who really has access to your data. And in terms of agenda, I'm going to try and cover three different things and build up on this and give you some real world examples to help frame that title that you saw in the previous slide. So I want to reintroduce some elements of identity concepts, which will probably be familiar to you, but I'm kind of building up the groundwork here back to the title that I just mentioned. And as I say, also give you some real world examples about how we see an identity being compromised and exploited to undermine the data security and protection that we may have in place. And come back to this point of, well, really who or perhaps what do we need to consider when we think about protecting sensitive data or data that we need on a day-to-day basis. So let's start with point number one. As I say, this may not be new information to you, but I want to use it just as framing this discussion that we're having today. I've taken a link here from, as you can probably tell, I'm based out of the UK. So I went to the NCSC, which is the UK government's cybersecurity centre, and looked at what they refer to as an aspect of identity management. And as you can see here, what's really important, again, not mind-blowing information here, but this is how we establish at both the initial point of contact and continually through further interactions who somebody or what somebody is. All right, it's the identification, authentication process. And I think all that kind of makes sense. The other thing that's really important on the identity side and what plays into the term of identity security that you saw on the very first slide is, well, the principle of least privilege, which is I think really important when we think about who's got access to the data and why. Because the principle of least privilege, and this time I went stateside, I went over to the US, I went to the NIST and looked at their definition of least privilege, which is that really from an architectural standpoint, from a solution standpoint, it's all about giving users the right access for the right reasons at the right time. Right? And again, that all makes complete sense, especially when we think about giving our users and teams access to data. They should only be able to see the data that's relevant to the role that they're doing. But what I want to do is kind of just start to develop a story where that may not always be the case, where that minimum access or that least privilege access that some users may have perhaps gives them access to things that they don't need to see, but because of the nature of the role, because of the nature of the access that they're being granted, that they may be able to see some of that data. And to do that, I want to do it's Thursday morning, so I wanted to perhaps make this a little bit educational, a little bit more fun. So dive into some historical examples of where we've seen identity being compromised and build this into a very recent use case and use that as a context to explain what I mean about really who's got access to your data. So as mentioned, let's have a little bit of a look back in time. I'm going to go all the way back to the time of the ancient Greeks, which might seem a bit strange. But really the point I want to make here is that the challenge of establishing who somebody is and what they should be able to be privy to, what information they should be able to know, it's a problem that we've had for millennia, right? In the time of the ancient Greeks, ancient Greek armies would use passwords and passphrases to help identify soldiers from the same side. Right? So if they knew the password, if they knew the passphrase, okay, this is someone we can trust, this is someone we can relay information to, etc. Now, of course, there's a challenge there. If that password falls into the wrong hands, then perhaps a malicious, or an enemy could be now impersonating someone that we trust. My focus isn't on the physical side of identity. My interest isn't here about how do we prove an individual is who they are, because we have things like passports and identification cards, etc. My real interest is what happens when this problem becomes a digital problem. All right, so I'm going to fast forward now to the first time this whole identification problem became a computer problem, became a digital problem. And to do that, we move all the way into the 1960s. And what you can see in the picture here in the background is something called the Compatible Time-Sharing System that was built in the MIT University in the United States. The gentleman that you see pictured is Dr. Fernando Corbato, who sadly passed away a few years ago. But the reason I'm sharing you this slide is he had to solve a problem. The machine that you see here is one of those old school big mainframes, took up a whole room, and it was used by researchers at MIT to, of course, process information and algorithms that they were working on. Now, the benefit of this solution compared to historical ones is it wasn't a dumb terminal. Different users could use it at concurrent times. And so the problem he had to solve is, well, these researchers needed to save data that they were working on. And therefore, there was a private data issue. How can a researcher share or store, the private data for them that they can access next time round? The second challenge he needed to solve was this was a huge machine. It was very much in demand. They only had one, expensive to run. Only so many people could use it at a time. So they had to enforce restrictions, time restrictions on how long someone could use it. So they basically would limit a researcher to 4 hours. They could use this terminal for 4 hours a week. After that, their time was up. They'd have to wait for their next allocation of time. So how did he solve this problem? Well, he introduced the computer password. This is the first time back in the early 1960s that we see the introduction of the computer password to help identify people on a digital system so they can only access data for themselves, but also allow them to solve the problem of the time sharing. As I log in, David Higgins logs in, I get my 4 hours, and then it knows that if I try and log in again afterwards, sorry, David, you've used your time. Now, I share this because it's the first introduction of how we try to solve that problem of who accesses data. But it's also, 1 year later, the same time we see the underlying IT systems being compromised. Because in 1962, a PhD researcher discovered that all the username and passwords for all the researchers at the university were stored on a file. And he found that actually he could request to have that file printed off on an overnight batch job. Security was still in its infancy at this point. But he found that file and said, oh, I wonder if I can get that printed. And it did print out. At that point, he had all the username and passwords of all the researchers. His intentions were not malicious. He wasn't there to actually see the data for his colleagues. All he wanted to do was use their time. He wanted to get more time on the mainframe and was able to do that. So in the 1960s, we have a solution to the problem of how do we give access to private data and identify users on digital systems. And we also very, very quickly have the first example where that gets undermined. So bearing that in mind, as I say, I wanted to kind of build this up a little bit, but I think it's, of course, relevant now that we fast forward back to today. And again, I want to give an example where we saw some malicious activity. And I want to pick out some aspects of a breach, of a data breach that happened that I think is really important to the title of the session that we started with, right, about who has access to your data. So to do that, let's talk about hacking a Vegas casino. Some of you may have known there were reports, of course, last month that MGM Resorts were unfortunately the victim of a cyber attack. If you head to our website, by the way, there's a lot more detailed information about what we believe happened. But I want to just highlight some key points to you that's really going to build back into, as I say, one of the key elements I want to share with you. So here, there's a lot of information going on. Don't worry about digesting it all at once. I'm going to kind of talk you through some of the interesting points. It's sequential, so you can see we've numbered what's happened. But really what happened in this attack is that the attackers started to gather intelligence about MGM employees. And then they were after very specific employees. And this is a point that we're going to come back to. But they chose specific victims, specific employees of MGM that they were interested in, gathered more information about them through applications like LinkedIn and information that was available online. There's also perhaps the possibility that they purchased stolen credentials off the dark net. If you're not aware, a lot of the time when individuals or when we see these data breaches taking place, information ends up on the dark net, not just data, but in many cases, user credentials. Attackers can actually request to buy credentials for a target victim and say, well, I want to hack that organization. Let me see if there's already some stolen credentials I can use. attacks are becoming commoditized as it becomes very lucrative business. But anyway, in this case, they identified some individual employees that they wanted to focus on. And then what they did is they called the help desk, impersonated that employee in an attempt to get the help desk to reset their multi-factor authentication tokens, because they wanted to be able to log in as these users. Now, as I say, there's a lot of things that we could unpick about how that happened through, education and various other things. The piece that I want to really pick out is what happened afterwards, why they targeted these specific individuals. Because as you look at point 4, you see the continual reference of administrator. I'm not really talking here too much about Okta and Azure. It's not really relevant what technology MGM were using at this point. What I want to highlight is that the attackers focused on these highly privileged, highly administrative users before they then executed on the exfiltration of sensitive data. They also executed some damage as well by encrypting, as you can see, ESXi servers, that's virtualization servers. So they actually caused some service outage to MGM as a result. And I believe that was to do with the fact that they weren't willing to pay the ransom. So there was a little bit of, the attackers just executing on their threat, shall we say. But as I say, that bit there is really interesting to me. I'm not really wanting to talk anymore about data breaches and cyber attacks. I want to dive into why attackers find it so useful to go after these administrative users when it comes to accessing data, and not perhaps targeting the application users, who are the genuine users that need to see and process and access that data. So if we look on the next slide, very simple view here, and it will change depending on your organization, but I've massively simplified the kind of application stack, right? At the top layer, we've got the actual application interface, right? Think like a web interface. It could be a thick client, but this is the way that users gain access to the application, whatever that app is, whether it's an HR system, whether it's a payment processing system. You can think of many examples, no doubt. Then under the covers of that, we're going to have differing layers. Middleware, which will be things like your database, where data may be stored. The operating system that the application and database run on, Windows, Linux, so on and so forth. The hardware, and in some cases that could be virtualized or could be physical. And in all those scenarios, some of these layers actually may be something we consume as a service, right? It could be a SaaS-based application that we consume, like a Salesforce or Workday. It could be that we're consuming infrastructure or platform as a service from AWS, GCP, or Azure. So some of those layers actually may not be the responsibility of your organization. Regardless of that, the point I want to highlight here is the actual individuals that need to see the data that that application uses and processes are, of course, the authorized users. And we put them through role-based access control and make sure that the right users have access to the right applications and right entitlements within that application. But of course, under the covers, there's a whole team of users that need to maintain and operate these systems. So we have the administrators, and we have automated processes. We have scripted processes that are ensuring that these applications are built, that these databases are up to date, that the operating systems are patched and maintained. And to do that, they need highly elevated access rights. So why focus on the admins? Why are attackers going after the administrators? Well, it's because they have the elevated rights. They have those far-reaching privileges that if they can take over an administrator account or that of an automated process, and I'll come back to that in a second, then it's going to give the attackers that step up. They have the elevated access rights to a lot of the underlying systems, which by a consequence gives them access to a data. Right? Think about database administrators. Right? They're there to build databases, maintain them, ensure that they're continually functioning. So they need admin access to that database. And as a consequence of it, they may also be able to see the data that resides in there. Of course, you could talk about encryption to make that less of a challenge, but still someone has to manage and maintain that encryption. So the point kind of is still there, is that we have users that genuinely need to access applications and data. We have administrative users that need to maintain and keep those systems running. But because they have to have elevated or privileged rights to do that, as a consequence, they may also be able to see the data. They may also be able to shut down the systems, which is why we see would-be attackers kind of going after them. And it's not just the human users in your IT support desks and administrator teams that are being looked at here. A lot of what's happening today is organizations are embracing automation, right? So using automated processes, perhaps it's a scripted process or a batch process that moves files from one location to another. It's a pretty mundane manual task for a human user to do it. So if we can automate it, brilliant. So what we do there is we enable scripted processes, code, etc., to perform these tasks. And to do it, they need the same level of privileges that we would have given to the human IT admins anyway, right? So we now also have, as I mentioned before about who or what has access to your data. Well, we also have to consider that we're giving non-humans access to our data. Think if any of your organizations are embracing things like robotic process automation, which may automate one of the tasks that I just talked about of moving files, or maybe it's a processing script that needs to be done. It's a processing of data that needs to happen on a weekly basis to generate some reports, whatever it may be. We're giving that non-human entitlements and privileges to access, to see and process that data. Now, I'm not implying that the machine themselves is going to maliciously leak that information, but we need to make sure that if we're allowing a scripted process, an automated process, that it needs to fall back into some of those principles that we talked about at the very beginning, that we are properly authenticating that machine. How do we know it is the legitimate script requesting access to our data and not a would-be attacker that knows we're enabling that and is somehow trying to impersonate the machine? How do we make sure as well that the machine only has access to systems in line with the principle of least privilege that we also mentioned before? Something else I want to call out as well is why do we see attackers focus on admins, and why we also, as organizations, when we look at protecting our own data, need to consider the administrators. It's because a lot of you probably have a centralized IT function. Now, when you think about all the different types of apps and file shares, etc., that you may have, it's likely, of course, that it's particular users that have access to particular applications, right? And we could break that down in a role-based approach. But we centralize the IT administration function. So actually that one same group of users will have access to a range of underlying platforms. So again, this is why we see those administrators being focused on, both by malicious actors, but also a consideration that we need to have when we think about really who does have access to our data. So when I look at this from an overall perspective, and the term of identity security I mentioned before, this I think is a key challenge for organizations, is not just looking, if I get the laser pointer here, not just looking at the right workforce users having access to the right data, but also those administrators are external third parties who are maintaining the underlying systems. Because of what they do, they may, as a consequence, have access to that data. That may not be something we're able to change. It just means we need to have the right control processes in place to ensure that these users, in line with the kind of mindset of a zero trust approach, are only getting access as they need it for legitimate reasons, and it's not perhaps a malicious actor that's compromised that privileged access, or of course a rogue employee. And there are numerous examples of disgruntled IT employees who have leaked data, destroyed data, because they have that far-reaching access, and perhaps they didn't get that pay rise or that promotion that they were promised. And importantly, it's not just about who, but it's also about what has access to our data, because we're embracing automation in this day and age, and we're giving a lot of access to our sensitive systems, to non-humans, to perform automated tasks. So again, there's a challenge there that we need to consider. How we solve that, of course, I could spend the next several days talking to you about that, but I don't have time to do that. So I'm going to skip that and say, if you would like to know more about some of the things I've talked about, how we can address some of those challenges, do you want to know more about some of the breach example that I gave? Feel free to hit our website. At CyberArk, it's something that we've focused on a very long period of time, is how do we protect all the different identities that you've got in your environment, making sure that they're only able to access the systems, the data, and the platforms that they should do as part of their actual legitimate kind of role. So hopefully that was of interest. And I think I'm just coming up to time here. So look, I'd like to hand the floor back to the Bitkom team and thank everybody who has attended my session. I hope you found it useful, and please feel free to reach out via the email, via the website address that you see on the screen right now.